Welcome to the viewers. We discuss today the idea of homeomorphism and what homeomorphism is. Actually, it is a concept in topological spaces, and there is basically for one-one and onto mapping and as well as continuous. This concept is called homeomorphic concept. And before discussing this, all the newcomers who are watching my videos are advised to subscribe the channel at first and always press the bell icon. Now let's watch what happens. Now let us come to the part of definition. A 1-1 and onto mappings or function g from x1 tau 1 to x2 tau 2, then this function is called homeomorphic or this function is said to be a homeomorphism if G and G inverse are each continuous. And here, if we observe in these two topological spaces, here it's this topological representations. If x1 it is tau 1 and it is for x2 tau 2, and there is a function g from x1 to x2, and then we find reverse function, that is g inverse also exists, and doing this already we backing the main function. And if we observe it, that's this function are continuous, because if we find any function, say any elements, whatever may be the element is, like v, or if we say that's a v, then we certainly find it here g inverse of v in this area operated with, and both g and g inverse are each continuous, both are continuous, then we called this is a homeomorphism idea. This is the main concept of homeomorphism. And if we say the identity function, if we consider identity function, if we denoted by I from x1 tau 1 to the same space x1 tau 1, or it may be represented I from x tau 1 to x tau 2, and the different type of topology we used on the same space, and the space may have different topologies. Whatever may be the topology is, there are the two topologies exist here, the same space. For better to write it here only x, not write x1, but if you write x it's better on notation, but it's also correct. The same space, that means the same space, two different topologies. This is the identity functions. As for example, if we take that is example, that is we can say it, that's I, if an element, if we say as x, that will certainly be x for if x is belongs to the element x, capital X, and this x is the element of tau 1, and this x operated, that's element of tau 2 after operations. Different topologies but same space. And in cases of a real valued functions, if g is a real valued function, then g from R to R, that is, we take R, that is real number system, with usual topologies for reals, and always we remember that's open interval from a base, that's form a base if we get from the definition of f is continuous at a point x0 of R, that's form a base if we say. And clearly from definition above, if f g, here we consider g arbitrarily, g is continuous at a point, say whatever may be the arbitrary point is, at a point x0 belongs to R, if corresponding to arbitrary epsilon greater than 0, corresponding better to right, corresponding epsilon greater than 0, there is a delta greater than 0 such that we find it here, that is f of g of x0 arbitrarily, g of x0 minus epsilon less than gx less than g of x0 plus epsilon, that is mod of g of x minus g of x0 is less than epsilon, whenever that is the definition of delta, x0 minus delta less than x0 plus delta, that is mod of x minus x0 is less than delta. That means if we observe this as corresponding epsilon and corresponding epsilon greater than 0, we find this result, and here we find this is a neighborhood actually, if we observe that is epsilon neighborhood, and correspondingly we find here delta neighborhood, and this definition of continuity of f, this is the definition of continuity of G, that is with actually it is epsilon delta definition, and here we find that is epsilon neighborhood, and here it is find delta neighborhood, and this is the definition of G as classical analysis continuity. This is the definition of G. This is an observation of continuity of G in classical analysis. That means here topology, that is called the modern analysis, and with this explanation with the neighborhood point we can easily get these corresponding terms in classical analysis and clear the idea of continuous functions. So in this way we discussed this, we finished our videos. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.